Okay, we continue to the perpendicular bisector line, which is the perpendicular bisector line is another straight line that will pass the midpoint M here with of line of AB, which is perpendicular, and the gradient is 90 degrees toward each other. So the equation is M1 plus times M2 equals to -1, or M here times the gradient of AB, line AB is equal to -1. So we proceed to the example 15.2. Given the point of C and D, which is C equal to 3, 0, and D -3, 2. So for the solution, at the first step is we have to find the gradient of CD, gradient of a line CD. Okay, so the gradient equation is y2 minus y1 over x2 minus x1. So from here, this is a x1, y1 with the point of x2, y2. So y2 is equal to 2 minus 0 over -3 minus 3. So we get 2 over -6, and we get -1 over 3. So here, with the perpendicular bisector, gradient MP times the gradient of CD will become a -1. So the gradient of perpendicular bisector times -1 over 3 equals to -1, and we get the value of MP is equal to -1 over 3 equals to -1 times -3 over 1. You get 3. Okay, so after that, we're gonna do to find a second step is to find the center point, which is the midpoint of line CD. Okay, so we know which is the x1, which is called xo, yo. So solution is the equation will be x1 plus x2 over 2, y1 plus y2 divided by 2. So x1 is equals to -3 plus 3 over 2, and 0 plus 2 over 2, and it becomes, this is equal to 0, 0 and 1, 2, 2, 0 and 1. So xo, yo will become 0 and 1. So, and then for the third step, to get the perpendicular bisector with the equation of a standard formula, line standard formula, y minus yo is equals to m, or gradient of a perpendicular bisector, times x minus xo. So y minus 1 is equals to 3x minus 0, and so y minus 1 equals to 3x, y equals to 3x plus 1. So this is the equation, the answer for example 15 2.